Hello, good afternoon, good evening, good morning. Welcome back, all of you, to I believe the last session of continuity. So, finally, let's not talk in advance, but I hope that today हो जाएगा. Today we will be able to finish this particular exercise which has been taking so long. Of course, there were 34 questions which we had to do. So today we will be trying to solve as many questions as possible and wind up the exercise so that we can move on to differentiability. That's a small topic, and then yes, finally differentiation. So I'll not be doing all the questions here. Okay, we'll be just picking up some questions. So we'll be trying to keep this session also just short, just like yesterday. And of course, we have done actually all the big questions. So we have some application questions, some nice questions are there. And these questions usually come, okay, for 2 marks and so on. So these are also an important part of the exercise. So you can just get ready, bring out your book, pen, paper, textbook, sit on a table, get ready, exercise yourself, stretch your arms, and then we'll begin in just a moment or two. So you can get yourselves ready. This is the first question that we will be doing, question number 26. Of course, the general question A. So that the function f is continuous at the indicated points. Our indicated point for question number 26 is x equal to pi by. A very good evening to each and every one of you, all those who have joined today. So now you see, you're supposed to find out the value of k so that the given function f is continuous at the indicated points. This is the function that is given to us. The indicated point is x equal to pi by 2. Good evening all. So let's just begin. Okay, slowly let us just begin. At x equal to pi by 2, the given function is continuous if we don't have to prove whether it's continuous or not. You're just supposed to find out the value of k for which the given function at the indicated point will be continuous. So it is at x equal to pi by 2, the given function is continuous only if the left hand limit, that is x tends to pi by 2 minus f of x, no? Is equal to the right hand limit, that is slightly greater than pi by 2 for the function, is equal to the value of the function at x equal to pi by 2. Then only we can say that the given function is continuous. So we have to fulfill this particular condition, then we can proceed and find the value of k. Good evening all. So that's it. So I hope you're all getting ready. We shall begin very soon. Good evening all. So I'm going to write about the upper part of the question, okay, so that we can just get ready. In the meantime, your friends will be joining, I am sure. So as we wait for some of your friends, please do not forget to share, like, subscribe the channel with everyone, because the lockdown is just going to continue. And schools definitely are not going to reopen, so let's all learn together and let's help others also learn, because knowledge is always meant to be shared. Okay, so fine then. Let's find out the value of k. So let's see what happens with the functions. Let's start with the left-hand limit. So I'm going to write directly. So left-hand limit, I'll start straight with the interval h of 0, f of 0. Our point is pi by 2 minus h. Left-hand limit, so I'm just starting directly pi by 2 minus h for the interval straight up. Okay, you can begin like that also. So that will be limiting value as h tends to 0, pi by 2 minus h. So whenever it's not equal to 0, our function will be k into cos of pi by 2 minus h divided by pi minus 2 into pi by 2 minus h. Alright, so I am going to say bye-bye to this question. So again, trigonometry again. क्या करेगा उपाय नहीं है trigonometry. Now cos of pi by 2 minus h, if you remember class 11, cos 90 minus h, given class 10 also, that is sin h, pi by 2 minus, so 90 minus, right? And this will be pi minus 2 into pi by 2, that will be pi minus into minus plus 2h. So pi we can cancel. 2 I can take out. What? Limiting value as h tends to 0 sin h upon h. Pi cancel, so 2 and k I'm just taking out because these are constants. So we'll be left with sin h upon h. So this value is k by 2 into, we know that this value is 1. This is almost at the end of the exercise. So that will be k by 2. So we still have to find out the value of k. Okay, so this value for us here is k by 2. Fine. Good evening, all of you. Senda, Imchen, Imtia, Tinutums, all of you. A very good evening. So this is the left-hand limit. Let's proceed with the right-hand limit. These are simple questions, okay, at least compared to the previous questions. Again, that lazy person is again going to start with right-hand limit from here. So right-hand limit will be f of pi by 2 plus h, where for a small interval, h tends to 0. So this will be palas, this will be palas. So there will be some small change, of course. So that will be cos of pi by 2 minus, plus h. That goes to the second quadrant. So that's going to be minus of sin h. This, of course, pi minus twice of h. Of course, here pi gone. So okay, let me just write down once again. H tends to 0 minus k sine of h divided by minus 2h. So minus cancels, k by 2 can be taken outside again. So limiting value as h tends to 0 sine of h divided by h. So here also we have k by 2 into 1. That's again k by 2. So you can go back to equation 1. Of course, sorry. You can mark that equation which I gave you now, that for a function to be continuous at x equal to pi by 2, the left hand limit is equal to right hand limit is equal to f of pi by 2. You can mark that as equation 1. Got it? You can mark that as equation 1. Okay? Alright, so that is done. So let's find out, okay, what is the value of f of pi by 2 also? So it's given in the question. The value of the function at the point x equal to pi by 2 is kitna? 3. So from equation 1, what we have here is k by 2 is equal to k by 2 is equal to 3. So you can just take any one of the term. And that implies anyway k by 2 equal to 3. So k ka ho how much? 6. So the value of k is 6, for which the function can be continuous at x equal to pi by 2. Got it? Alright. So now we will move to question 28, because 27 I'm sure you can do it. So we'll just skip to now 28. Easy questions, at least something should be left for you also. Everything if we just do, not good enough. Because some of you are complaining that, sir, you're doing all the questions for us. At least leave some questions for us also. Chalo, theek hai, I will have questions for you. No, I'm just kidding. No, but seriously, there are some questions which are easy questions, which I believe you can also do. So you can give it a try. If you are not able to, then you can let me know. You can let me know in the comment section below. So the value of the function is kx plus 1 if x is less than or equal to pi. Cos x is equal to if x is greater than pi at x equal to pi. Okay. Actually today our main attraction is question number 31 onwards, 31, 32 and especially 34. So that's where we are running after. So let's do this chota mota questions in a hurry. So let's begin quickly. F of x is continuous at x equal to pi if limiting value as x tends to pi minus left hand limit is equal to limiting value as x tends to pi plus, that's the right hand limit, is equal to value of the function at pi. Then we can say that the given function is continuous. So let's start with the left hand limit. So I'm going to start straight with the interval h tends to 0, f of our value pi, so that will be pi minus h. So limiting value as h tends to 0, pi minus h. So these are values slightly less than pi, now pi minus a small interval h, so pi minus h. So pi minus h, so whenever the value of x is less than pi, which function are we going to use? Less than or equal to kx plus 1. K into x plus 1. So that will be k into pi minus 0 plus 1. So that will be k pi plus 1. Of course, you can mark this as equation 1. That's what I was telling you. If you still haven't liked the video, at least give me a like. Chalo, chalo. Come on, yeah. Give me a like. Chalo, chalo, chalo. For motivation, at least chalo, chalo, sir. क्या है एक like दे देगा. Don't give me a dislike. Okay, so that's the left hand limit. Okay. So that lazy person is again going to continue with the right hand limit. Like. I'll just continue again. Left hand limit हो गया ना? So I'll continue with right hand limit. So here itself I'll just write down right hand limit is equal to, that's for this one, so pi plus h. But of course the function will change. Pi plus h, that represents a value that is slightly greater than pi. Slightly greater than pi, this one. So it's cos x. So that will be cos pi plus h. So that will be limit as h tends to 0. What is the value of cos pi plus h? That goes in the first, second, third interval, third quadrant, cos pi minus cos h. Anyway, this is just simply minus cos 0. So that is again minus 1. So from equation 1, what do we have? Our left hand limit was k pi plus 1. No, left hand limit, I think the value was k pi plus 1. The right hand limit, we get minus 1. And the value of function at pi is again k pi plus 1. So, from this we get, that implies k pi plus 1 is equal to minus 1. So that is k times of pi is equal to minus 1 minus 1. So that's going to be k times of pi is equal to minus 2. So k is equal to minus 2 by 5. Bas. Simple questions. These are simple questions. Okay? Alright, so 29 again, I'll leave it for you. We'll go to 30. Okay, so this question is also similar again. Find the values of a and b such that the given function, okay, लिखना तो भूल ही गया, is a continuous function. Such that the given function is a continuous function. Such that the given function is a continuous function. So the function is a continuous function. Now for continuity, generally what happens? Continuous functions, we need points. We need what? Points. Points are very important. So from here we can clearly see that our points are what? That the points that we have are 2 and 10. So solution. So f of x is continuous at x equal to 2 and x equal to 10 also. Because for any value that is x less than 2, that is also 5, constant function continuous. Greater than 10, 21, constant function continuous. Between 2 and 10, this is the function that represents a polynomial function. So the function is continuous only. So we need points. So f of x is definitely like continuous at x equal to 2 and 10 also, because it says it is already a continuous function. So with the help of that, let's get some equations and find out the values of a and b. Let's start with the point 2. Let us start directly, that is limiting value as x tends to 2 minus f of x is equal to limiting value as x tends to 2 plus f of x, that is equal to limiting value of f of 2. I'm just going to start with in just one sentence only. So that will be limiting value as h tends to 0 f of 2 minus h. This is, after that we can arrange h tends to 0 f of 2 plus h and f of 2 5. The value of the function at x equal to 2 is given to us, it is 5. Yeah, so I don't want to be rubbing the question also, but okay, I'll just adjust here. So I'll just continue here, okay, because I need this for you. So 2 minus h, so whenever it's less than 2, what is the value of the function? 2 minus h means represents a value that is less than 2. Less than 2, that is also fine, not a big problem there. What about the right hand limit? H tends to 0, 2 plus, that's slightly greater than 2. We have this function ax plus b, so that's going to be a. What is the value of x here? 2 this plus b. That's equal to 5. So 5, 5, so we can just take one equation, that is, so that will be, so that implies limiting value as h tends to 0, 2a plus ah plus b is equal to 5. So that's going to be 2a plus h into 0, 0 plus b equal to 5. Yeah, condition is given to us in the question. We get our first equation, that is 2a plus b equal to 5. Oh yeah. Remember, we have to find out the values of a and b. Alright, so that's it. That's what we have. That's the information that we can get from the point x equal to 2. Let's see what information we can get from the point x equal to f of 10, x equal to 10. Less than 10. Sorry, less than 10 is this one. Again, a into x plus b. Greater than 10. 10 plus h, again greater than 10, 21. This is also 21. So we can just write directly, that is a into 10 minus 0 plus b is equal to 21. It just implies. So then what do we have is 10a plus b is equal to 21. That's our second equation. So now if you compare equation 1 and 2. So from equation 1 and 2, we'll take the help of those and then we'll start solving. So what we can do is now, let's just subtract equation 1 and 2. So what was our equation 1? Equation 1 was 2a plus b. Plus b minus equation 2 is 10a plus b is equal to 5 minus 21. Okay? Alright, so it's not that difficult, isn't it? Not that complicated. This, of course, we have, since if you have already learned what are continuous functions, it won't be difficult for you. Alright, so now let's do some other simple questions. I hope you have got algebra of continuous functions. Now, I hope you have gone through that particular video. I provided a link in the previous video. So if you haven't, you can just go and check it out later on. That's the advantage of YouTube. No, you can just go back and back and back as many times as you want. So here generally in almost all the questions, the algebra of continuous functions, the concept of algebra of continuous functions will come in very handy. Of course, here another concept that is regarding composite functions concept will be required. So let me just tell you briefly. Composite functions also once previously I had done. So I hope you're following all the videos. So, but anyway, we'll be doing that again with Unit 1, Composite Functions. There's a topic where we'll be learning these composite functions in detail. So we'll be studying that also very soon. So, but in brief, composite functions are just like functions which are on, two functions combined together. Of course, there are conditions, is the domain and range. There are certain conditions, but let's not focus on the conditions now because we're not trying to learn composite functions. We're just trying to get composite functions in case if so something like a summary. So composite functions are like one function put inside another function. All right, sugar in boiling water. So it's like one function being put inside another function. That means, for example, like this. If you have x square and the other function is g of x is, let's say, 4y. Let's just say that 4y, g of y. Functions, then the composite functions, that is like we represent it like something like this: f on g. There are two ways. Of course, there are conditions also, but at least for now, let's just ignore the conditions now about the domain and range and all. Let's just ignore that conditions. F on G will be right something like f of G, that is of Y. Okay, let me not confuse you. Let me just use X itself. That will be better. So f of or on G of G, that will be f of the function G. So that is like f of, what is the function G for X? So again, after that, again, what is the function f? The function f is x squared. What is x here? Replaced by 4x. So it's x squared. So that becomes 16 with x squared. So it's like one function put inside another function. So the outcome becomes different. In the same way, we can also go for g on f. That will be what? G of the function f of x. So g of, what is the function f of x? That is x squared. And what is the function g of x? 4x. That is 4. What is the value of x now? It's x squared. So 4x squared. So you can see that the f on g and g on f are different, definitely. But that's the basic concept. So like one function put inside another function. These are known as, composite functions. Okay, composite functions. So we will be requiring that concept here today, especially this remaining few questions. And then plus, if you have your, all the notes written down for you, you will see in those some, if you have two functions, f is also continuous function, g is also continuous functions. I hope you have written it down. Please do go back and watch those videos also. Okay, those are very important. So that's why I had made a special separate video on that only. So if you have f as a continuous functions, g also as a continuous function, then their composite, if it exists, then the composite function is also continuous. And the composite of their function is also, the composite function is also continuous. Of course, if they exist. Alright. Similarly, we have also seen that if f is a continuous function, g is also a continuous function, then their algebra, that is f of plus or minus g, is also a continuous function, f into g is also a continuous function, f by g is also continuous functions. So just all those concepts will be required here. Alright, so let's finally go back to the question here. So as you can see here, solution, very simple question, f of x is cos of x squared. So you can see that this is not simply a trigonometric function. We have here two functions here, trigonometric, algebraic function, or a polynomial function. So that means this is broken into two functions. So we'll have to identify that. So like if we just assume g to be cos x and h to be x squared, then I think you're getting to understand, isn't it? Then you can see that cos x squared is a combination of these functions. The combination of these two functions. And then you will see. Then what will happen to h or on g? That will be, let's see, h of the function g. You can try it both the ways. So that will be h of cos x, because the function g is cos x. Now what is the function h? That is x squared. So that's going to be what? Cos of x squared. No, that's going to be different again. So that's going to be again cos x squared. So h on g is not working out for us. So that means h on g is not working out for us because our function h is x squared. So what is x here? Cos x whole square. No problem. Let's check for g on h. So that's going to be g of h of x. So that will be g of the function h. What is h of x here? The function, this is x squared. And what is our function g? It's cos x. Cos x. What is x being replaced by? X squared. So that becomes cos x. What is cos x? That is cos x squared. So that means clearly it is a composite function, g on h. So that way you can try. Now, if you don't not get around for h on g, then definitely it will be for h, g on h. Every time it's not about guessing also. So you can try both, definitely one. Alright, so it's proved that this function is a composite function of g and h. Alright, now we're done. Now let's talk separately. Now g of x, that is cos x. Yesterday we have already seen that cos x is, I'll just write in short, continuous function. H, it is x square, is also a continuous function because this is what? Polynomial functions. So from algebra of functions, we have seen that polynomial functions are also continuous functions. That's why if you know the theorems, if you know the algebra of continuous functions, it becomes very easy for you. So from then what happens? Then the composite of two continuous function is also continuous. That's from algebra. I'm not saying it, that's the algebra of functions saying. So f of x is equal to cos x square is also continuous. So it's a very simple and a very small proof. Good evening all, good evening Katikina Maramanan and all, good evening. So you can see that it's a very small proof, provided yes, you know your stuffs, you know your concepts, then it's easy. Because here you don't have any intervals, you don't have any limits, so either you will have to take maybe at the point in the arbitrary value a, but that's not going to be that easy, so it's going to become very big. But if you know your algebra of functions, then it becomes easy. And don't worry about composite functions. Definitely you'll be doing that in unit 1, or you may have already done that in unit 1 also, in functions. So you know how these things turn out. Alright, fine then. So that's how we will be doing this particular type of questions. Likewise, let us try 32 also. Question number 32. Before we really jump into 34. So I'll be doing one more question, that is question number 32, sorry. Show that the function defined by f of x is equal to cos mod of cos x, absolute value, is a continuous function. So our function here is mod of cos x, mod x, if you remember mod x, modulus function. Of course, one thing is very clear, that f of x, that's mod of cos x, definitely what? Has a real value. Definitely cos x is always, will be giving you a finite value, isn't it? Real value, and of course, finite value. Yesterday I told you about sine. It lies between +1 and -1. Likewise, cos also will lie between +1 and -1, of course, for all x belonging to the set of real numbers. So of course, domain of the, here we will be talking of real numbers only. So that means domain of the function is of course a set of real numbers, or domain of f is set of real numbers. Alright, that gives us the assurance and we can proceed. Now, you will see that this is also what? A composite function, isn't it? We have here trigonometric function and we have here the modulus function. Now, modulus function in the previous videos, I think in some questions back, or you can just try to prove it also. Modulus functions are also continuous functions. Now, we will not go along to prove that modulus function is continuous here. It's already done before. Okay, so we will be just trying to prove that it's a composite function. I'll rub this part. So let us just assume that g of x, let this be one function, let g of x be, let's say, cos x, and h be the modulus function, and let h be the modulus function. Now let's try it. What will be g on f? That's going to be g of the function f of x. So that's going to be g of, what is our function f of x? Cos x. Cos x. So what is our function again? G? No, sorry. G on f. No. We have h and g, isn't it? We have here h and g. So let's try h on g. It's on this. Let's try directly. That is h. Again, I'm writing f. Yeah. H on g. That is h of the function g of x. So that is h of the function. What is our function? G cos x. Cos x. And what is our function? H mod of x. Mod of x. Cos x. So that proves that mod of cos x is a composite function, composite of g and h. Okay? So now all we have to do is, now g, I'll just write g, is a continuous function, because just previous problem also we have proved that we have seen that cos x is a continuous function, and h is continuous function because h is a modulus function. So the composite function is also continuous. So then f of x is equal to mod of cos x is continuous. These are very simple stuffs, but if you don't understand, if you don't have the basic concepts, then of course it becomes boring. No, these topics, conceptual. But interesting, very nice topics, this calculus. Alright, then the next question, I'll leave that to you. That's also a composite function only. So next question, I'm going to leave that to. Let's move on to finally 34. Fine, this is the last question again of the biggest exercise in chapter 5, I suppose. Alright, so you can get ready. I'll have a cup of water, glass of water. Now the solution to this particular question will depend on the marks. If it's a 2-mark question, we are going to solve it accordingly. If it's a 4 or a 6-mark question, then again we'll have to solve accordingly depending on the mark was. For example, like if this is just a 2-mark question, then we can do it very easily. I'll give you both quickly. Okay, I'll give you both of them. So if it's a 2-mark question, because like 6-mark and 4-mark, at least it should be worth writing, no? Especially in the board exams and all, isn't it? So that's why. So if it's a 2-mark question, we can clearly see that, like, now let G be mod of x. h. Of course, this is not a composite function, but again from algebra functions, if f and g are two functions, then f plus g, f minus g, f into g, f by g are all continuous functions, if you remember. So in that case, what happens? You see, then like g of x, this is a modulus function, so g is also continuous. H, this is also a modulus function only that the value is different, it's x plus 1, but still a modulus function. So fh is also continuous because both of them are modulus functions. So in that case, g plus or minus h is also continuous. So in that case, this given function is continuous. There is no point of discontinuity. So if it's just a 2-mark question, got that? Once again, if it's a 2-mark question, then like we can just write, this is addition of subtraction of difference of two functions. So g and h. G modulus function, h is also a modulus function. Now modulus functions are continuous functions. So g is a continuous function, h is also a continuous function. From algebra of continuous functions, addition or subtraction of two continuous functions is also continuous. Hence, the given function is continuous. So, which means that there is no point of discontinuity in the given function. That's how you will be writing. I hope I've written it down. Alright. So that means we already have the answer. We already know the answer. That means I've already given you the answer. Question is, find all the points of discontinuity of f defined by this. It's not necessary that there should be points of discontinuity. We will see. As I just said, there is no point of discontinuity in this question from the conditions. We do not know, but definitely not. It is all continuous only. Alright, now for a big mark question, or if you write in detail, then the first question will be slightly big. So get ready, last question of course. So come on, show some energy. So I'm also exhausted and tired, but chalo, last question, so I'm happy. So let's do it. Now you see modulus function, this function. Let's break apart. Modulus function, mod x. Mod x is x plus x if x is greater than or equal to 0, minus x if x is less than 0. Of course, you have to know the modulus functions. Otherwise, there is no other option. Again, rub kar diya. No, I just need some space, so that's why. And even this one also, x plus 1, this is also going to be x plus 1 minus of x plus 1. If x plus 1 is greater than or equal to 0, if x plus 1 is less than 0. That's the modulus function. It's just that the value of x here is x plus 1, only that. So if you just rewrite this a little bit, it's going to be x plus 1 minus of x plus 1. If this one minus, if it goes, then x is greater than or equal to minus 1. If x is less than minus 1. Now plus 1 goes there, so it's minus 1. Alright, so we have rewritten the function properly. Because we need points to prove or check whether or if we have any points of discontinuity or not. I hope you're all with me. Okay, now let's combine the functions f of x equal to. Let's combine because it's combination of these two functions. Now, how will you combine these two functions? Of course, you have to combine because it's a fraction of these two functions, so we'll have to definitely combine this and this function. So, how will you combine? There are many ways and many tricks. I'll give you some. That is, you first. So here it's positive, minus also positive, so x plus, okay? Now positive in which cases? This time, we'll have to sort out the interval also. Now you see, here x is positive. Okay, this is done something like this. Are you with me? Listen. Here x is positive. We are combining because minus, no? So we're combining. So I'll just write like this. So here x is positive if, okay, I'll just draw the number line. Look carefully. 0. So here x is positive is if x is great. Listen carefully, it's very interesting. If x is greater than 0, this side. And this one is also positive. I'm combining the positive and positive. I'll combine the negative and negative. From there, after that, I'll see if there is anything left. Here also positive if x is greater than minus 1. Here, if x is greater than minus 1. So what is the common region? This one. So in general, let's write down that is if x is greater than or equal to 0. Common region. Okay? Now I'll write down the negative values. You can please leave a small gap. We'll fill it up again below. Now for the negative values, that is minus x minus of, because our function was, remember, mod x minus mod x plus 1. So negative values minus x minus of, again, minus x plus 1. Now this one, at what interval? This one is at what interval? That is, again, now let's combine again. Now again the number line. This is when if x is less than 0. If x is less than 0. And this one if x is less than minus 1. If x is less than, common region this time here, if x is less than minus 1. Okay? I hope you're getting it. Now, something is left out. Some intervals are left out. Check. Let's see. Look here. Let me draw the number line once again. We have to check all the points of discontinuity if it exists, isn't it? Throughout the entire number line. So, this is not enough because in this process we have left a small interval. What is that interval? Let's find out. Let's just put 0. Let's say plus 1. Minus 1. Let's say minus infinity. Let's say plus infinity. So for the first one, it's x greater than or equal to 0. Okay? Second one is if x is less than minus 1. Less, so I'll put dotted lines because it is less than, not, strictly. So less than minus 1. This is equal to. So from 0, higher. This is strictly less than, so it's after minus 1. So now in that process you will see that this portion has not been mentioned. Hey, this portion has not been mentioned, so we will have to find out for that portion also. So now that portion will be x, what? Strictly less than 0 because equal to 0 already included. What is left we are going to write now. And this one here, minus 1 was not included, so this is greater than or equal to minus 1. Got that? Once again I'm repeating, this is strictly, greater than or equal to 0. This is strictly less than minus 1, minus 1 not included. So in that process what happens is this interval is skipped. So we are going to include that interval. X is strictly less than 0, that is not including 0, but greater than or equal to minus 1, including minus 1, because it was not included. Now let's see what happens to the value. So if x is less than 0, if x is less than 0, it is minus x. Minus will come, of course, because that's the function, mod x minus mod x plus 1. And if x is greater than or equal to minus 1, greater than or equal to minus 1, greater than or equal to minus 1, x plus 1. So that's how you'll be combining the functions, x plus 1. Here, no, the main problem with this question is not the solution part. Solution though is going to be very easy. You will also see it will be very easy. Here the problem will be this arrangement of these functions, distribution of these functions. It has to be done very properly. So this is the main part here. Okay, so that's why I'm spending some time here. So this is enough, that is not needed. So let's rewrite this function properly once again. So I'll just do it in the rough here, x minus 1. So x cancels, so we have minus 1. X is greater than or equal to 0. This one, minus x minus 1. So minus 2x minus 1. If x is greater than or equal to minus 1, if x is less than 0. And the third one is minus x minus plus x plus 1. 1. If x is less than minus 1. So that's our final function. So we don't have to write too many things. This is the last question, so. So have you located your points where we can have some problems, discontinuity? See, I will not mention, you can also mention that in your own words, because whenever it's greater than 0, whenever it's greater than or equal to 0, the value of a function is minus 1, so that's a constant function, so definitely it's continuous. No problem. If x is strictly greater than 1, less than or equal to 0, then it's a polynomial function. That's also continuous. If x is less than 1, that's 1. That's also a constant function. That's also continuous. So we are left with 2 points. That is, we are to now check the continuity at only 2 points, that is x equal to 0 and x equal to minus 1. Alright, so let's check at x equal to 0. So I'm going to do it directly, that is x 0 plus f of 0 minus 1, because it's equal to 0. 0 plus h, anything that is greater, again you see 0 plus h represents something that is greater than 0. So any value that is greater than 0, x, this function will correspond to minus 1. So this is also minus 1. This one only we'll have to solve. That is okay. I'll just rewrite that once again. Limit as h tends to 0, f of minus h is equal to minus 1. So you can see we are almost getting, we just have to confirm with this one. So I don't want to be rubbing this part, so I'll just manage here. So kindly write it down quickly. So I'll just continue. This is less than 0. When x is less than 0, we are going to use this function. Minus 2 into x is minus h minus 1 is equal to minus 1. Yeah, I'm doing great, but I'm exhausted. Actually, I'm not feeling very good for the past 4 or 5 days. Don't worry, it's not what you think. But I'm having some stomach problems. So by evening, it really wears me down. But anyway, as I say, learning should never stop. So I do not want learning to be paused just because that I'm not feeling 100%. So 80% is enough for me, or even 50% is enough. So as long as I'm 50% okay, I'll continue to teach. So far it's around about 60-70% okay, 20-30% not very good. But chalo, it's the last question. As I say, we should always motivate ourselves. So it's almost done. So it's x equal to 0 is already done. That's why I'm talking less today. I'm exhausted. So anyway, chalo. This is continuous at x equal to 0. So now we are left with just one more point. That is at x equal to 1. Minus 1. Let's continue. Minus 1. Minus 1 minus f of x equal to limiting value as x tends to minus 1 plus f of x, I mean slightly greater than f of minus 1. This will be, of course, limiting value as h tends to 0, f of minus 1 minus h, because our point is minus 1, remember. Limit h tends to 0, f of minus 1 plus h is equal to, what is the value of our function at x equal to minus 1? Minus 1 equal to, it's minus 2 into minus 1 minus 1. Because x equal to minus 1, we'll have to use this function. Now, you have to know how to read the functions carefully. Now, this one is slightly less than minus 1. You remember that, no? Slightly less, because minus 1 minus h. So, this is definitely going to be less than minus 1. Now for less than minus 1, see, you have to keep your senses open. Otherwise you will be just wasting time doing nothing when the answer is already here. Got it? So for x is less than equal to minus 1, less than minus 1, it's already 1. So you don't have to solve again, only for this. Because when x is greater than minus 1, then we'll have to go to this function. That is limit as h tends to 0. Minus 2 minus 1 plus h minus 1, and this is 2 minus 1. Almost there. So I don't need this anymore. You can get out. So that's 1 is equal to minus 2 minus 1 plus 0 minus 1. This is 1. So 1 equal to minus 2 into minus 1 minus 1 equal to 1. 1 equal to 2 minus 1 equal to 1. So 1 equal to 1 equal to 1. So here also you can see. So that implies f of x is also continuous at x equal to minus 1. Hence, there are no points of discontinuity. Of course, you can describe for x greater than 1, less than 1. No, there are constant functions, polynomial functions, and constant functions, and we can do that. But I think this is also enough. Whew. Finally, the continuity is done. So the next topic that will be is differentiability. So that's not a very huge topic, at least with compared to the textbook. I mean, these are very vast topics, but with respect to your syllabus, and I think exercise we have just one or two questions. Then of course we are going to move on to differentiation. Okay, so fine then. Thank you all for joining in. I hope you have enjoyed this session also. I'm sorry I was so I really couldn't be myself. All right, so anyway, thank you for your motivation, and that's all. All right, so till then, take care. Please stay safe, each and every one of you. I'll see you in the next session. All right, so bye bye. Thank you so much.